The proposed building is a green library that incorporates sustainable and environmental friendly practices. The idea of the proposed building comes from NTU, which is the greenest campus in Singapore. Over 97% of the building projects are certified Green Mark Platinum. The proposed green library is to be developed at Penang, which is the cultural and educational hub in Malaysia.
The building shape is designed in a circular orientation that allows for more evenly distributed sunlight throughout the interior space. Next, the building facade is made out of argon-filled double-glazed glass with low E coating to maximize daylight, reduce heat transfer and enhances insulation, while the horizontal shading is provided to control direct beam solar radiation. The library's grass turfing roof slopes at almost 45 degrees, designing to reduce ambient temperature as plants absorb sunlight. This design is also to mitigate water runoff and sewer overflows. The interior space design would be an open central space by eliminating the ceiling to establish connectivity between T-story of the library.
The library is designed to harness natural daylight for the majority of its interior area to minimize the use of lighting during the daytime. LED lighting is chosen as the major light fitting to be installed in the library because it has a longer lifespan and higher light efficacy compared to other common types of lighting. Hence, the choice of LED lighting will help reduce energy consumption and achieve cost saving in the long run. And to maximize the energy efficiency in the library lighting system will be divided into zones, each with independent control to allow for precise adjustment based on specific need and usage patterns. Daylight and motion sensor will also be integrated in the lighting system to automatically adjust lighting level according to natural light and occupancy, thereby improving energy efficiency and reducing power consumption. The design is aligned with FIDICOT EC03, which intended to reduce energy consumption, and is scored 3 out of 3 in EE2 under the GBI, which intended to provide flexible lighting controls and optimize energy savings. In addition, solar energy will be used as an alternative source of power to support the daily operation of the library. The building integrated photovoltaics in the form of horizontal sun shading will be installed to the facade of the building. The use of solar energy will help to reduce environmental impact and emission of CO2 by decreasing the reliance on fossil fuels and minimizing the carbon footprint associated with conventional energy generation methods. It is anticipated that at least 10% of the total electricity consumption will be generated by the solar energy. It achieved the FIDICOT EC04, which promotes the use of renewable energy resources, and score 5 out of 5 in EE4 under the GPI.
The library employs a zone ventilation system with a CO2 monitoring sensor to constantly control the CO2 level inside the library. The system adjusts the ventilation rate on a zone-by-zone basis in different sections of library to improve the air change effectiveness and ensure a better quality of air. The system is aligned with FIDICOT EN01, which aims to reduce greenhouse gas emissions. Moreover, the library will be designed with the installation of windows equipped with automatic window opener at the upper part of the wall to provide fresh air ventilation and increase indoor air movement through the stack effect, so that the building can exhaust hot air by opening high window electrically with a remote control that is more accessible for occupants. The total score in GPI is 3 and aligned with FIDICOT EN04. Additionally, air pollutant solutions such as low or zero VOC paint, air purifier, and product with NAUF will be implemented in the indoor environment of the library to remove air pollutants such as VOC, formaldehyde, and bacteria that might impact indoor air quality and human health. However, those solutions will consume higher price compared to conventional material use. They comply to FIDICOT EN03. Besides, the natural lighting of building will be designed with the implementation of skylight and sliding glass door. The installation of skylight and sliding glass door can help to maximize natural daylight entering the building, thus reducing the cost of artificial light. The skylight can apply at the lounge area and corridor, while sliding glass door can be installed at the main entrance of the library. The total scoring will be 6 marks and achieve FIDICOT AD03. As an acoustic environment is crucial in library, the building will install acoustic wall panel and underlayment for floor in the library that are environmental friendly to reduce noise pollution, thus setting up a more quiet learning environment for the public.
For sustainable site planning and management, the library is developed on a brownfield, not only repurpose existing land but also preserve undeveloped areas. It's located in a densely developed cities which facilitate cost saving and minimize transportation related emission through its proximity to necessary infrastructure. It aligns with GBI code SN1 with 1 point and complies to VD code EN10. Next, the library's parking area is enhanced with permeable pavement and bioswales, reducing stormwater runoff by draining water into the soil. Permeable pavement with lower heat absorption than concrete also lowers the surrounding air temperature. Besides, bioswales serve as drainage system when groundwater flooding. The bioswale plants can reduce carbon dioxide emission. The stormwater design achieved a 25% reduction, scoring 1 point for SM11. It's also aligned with VD code EN1. For water efficiency, the library has incorporated a rainwater harvesting system to reduce municipal water usage for non-potable purpose. Previously, rainwater was discharged directly to downpipe. Now it's collected in an underground storage tank, sustaining rooftop grass through an automatic sprinkler system. It also manages stormwater effectively, hence reducing the risk of flooding. This system aligns with VD code SO5 for water conservation and GBI's WE1 code, scoring 2 points for reducing potable water consumption by over 30%. Moreover, greywater system is installed in the library. Wastewater from washhand basin is collected, treated, recycled, and stored for flushing toilets. This system reduces water wastage by decreasing the demand for fresh water sources. It also minimizes the energy required for water treatment and distribution. The total score for WE2 is 2 points and is fulfilling VD code SO5 requirements. Furthermore, the library is equipped with water efficiency fitting, including sensor that automatically shut off, reducing water wastage and offering long-term cost saving that offset higher installation costs. Besides, dual flush toilet offer both low and high volume flush option. It helps to conserve water by using less water from liquid waste. This fitting scored 2 points for WE4 and aligned with VD code SO13.
Bricks used for constructing the library is green leaf brick or eco-green brick instead of common clay brick. Green leaf brick is a masonry brick that manufactured from 100% recycled materials. Eco-green brick is a cement-free concrete that manufactured using fly ash or palm oil fuel ash. No greenhouse gases are emitted during the manufacturing, leading to lower effect on urban heat island. Clean agent fire suppression system is adopted to replace conventional fire suppression system that can be either water-based or carbon dioxide-based. This is because the discharge of clean agent fire suppression system is environmentally friendly and non-hazardous that can provide multiple levels of protection for the buildings and the occupants. This system achieves GBI with 2 scores in code MR7 and VD code EC07. LT-based smart recall recycle bin will be provided near to the entrance of the library. This smart recycle bin will automatically recognize, segregate, and compress the waste. It is powered by solar power and it can be managed via mobile application to ease the waste management. The development of this smart recycle bin is to encourage proper waste disposal practices in everyone, reduce waste sent to landfill, and to save energy. This proposed library is to be partially digitalized, which will adopt e-book system and library management system. This aligns with GBI code IN1. To sum up, the final score of GBI for this library is 86, which has achieved platinum in rating.
The initial cost for rainwater harvesting system is 5,300 ringgit and the recurring cost is 500 ringgit for annual maintenance and 2,650 ringgit for replacement at an intermediate period of 30 years. So the life cycle cost for rainwater harvesting system is 15,230 ringgit in total. While considering the system could help save up to 30% of the library water bills, the installation of the rainwater harvesting system proved to be a cost-effective and environmental responsible choice in the long run.
The initial installation cost of zone ventilation system is 65,000 and the annual cost for operating energy and maintenance are 2,000 and 1,000 respectively. Replacement cost is 15,000 for every 15 years. Hence, the total LCC of the system after the consideration of present values is 244,000. Although the initial cost of installation is higher than conventional system, the LCC is within an acceptable range and it can consider a better long-term investment that brings additional benefits. In conclusion, we designed the Green Digital Library to minimize negative impact on the natural environment by means of adopting green practices such as careful site selection, use of natural construction materials, conservation of sources like water, energy, and responsible waste disposal. Digitalization of a library is the primary core of strategic planning which contributes to the sustainability. The design of our green building project is able to accomplish sustainable development goals. That's all from us. Thank you.